I'm going to continue doing those problems. So we're going to continue on to 51 now. So for 51, we're trying to show that 1 plus cosine of theta times 1 minus cosine of theta is equal to sine squared of theta. So for this one, we're going to use the difference of squares. So as you recall, that a squared minus b squared is equal to a plus b, a minus b. Using that fact, a is 1, b is cosine of theta. So this becomes 1 squared minus cosine of theta squared, which is 1 minus cosine squared of theta equals sine squared of theta. And of course, from the Pythagorean identity, we recognize that 1 minus cosine theta is sine squared of theta because remember that sine squared of theta plus cosine squared of theta is 1. So this becomes sine squared of theta, which is just what we wanted. Similar problem for number 52. Where we have, instead of cosine theta, now it's sine of theta. So we have 1 plus sine of theta, 1 minus sine of theta is equal to cosine squared of theta. Again, we use the fact that we have a difference of squares. So we know a, once again, is 1, and b is sine of theta. So this becomes 1 minus sine squared of theta. And of course, recall that sine squared theta plus cosine squared theta is equal to 1 from the last problem. So that gets us, once again, cosine of theta. Cosine squared of theta is cosine squared of theta. Everybody follow? Good enough. On to 53. Which has a similar problem. We have, for 53, we have secant of theta plus tangent of theta then we have secant of theta minus tangent of theta equals 1. So we have a difference of squares once again. So this becomes secant of theta, which is a, minus tangent of theta, which is b. This becomes secant squared of theta minus tangent squared of theta. And from here, we use the Pythagorean identity of course, 1 plus tangent squared of theta is equal to secant squared of theta. And from here, we know secant squared of theta minus tangent squared of theta is 1. So it is indeed 1. So 1 equals 1. Just like we asked. 54. We have sine squared theta minus cosine squared of theta is equal to twice sine squared theta minus 1. Okay, so for this one, what we need to do is change cosine using the Pythagorean identity once again. So we have a Pythagorean identity. Sine squared of theta plus cosine squared of theta is of course 1. Thus, saying cosine squared of theta is 1 minus sine squared of theta. From here, we take the 1 minus sine squared theta and substitute that for cosine squared theta. So, sine squared of theta minus parentheses 1 minus sine squared of theta is equal to 2 sine squared of theta minus 1. Distribute the negative sign. Two negatives become a positive. So this becomes minus 1 plus sine squared of theta, sine squared of theta, to 2 sine squared of theta minus 1. 1 plus 1 is 2. We leave the sine squared thetas alone. So this becomes 2 sine squared of theta minus 1 is equal to 2 sine squared of theta minus 1. So that's just what we wanted. So it's perfect. Yes. Last two problems, on to 55. So for 55, we have sine over cosine plus cosine over sine is equal to cosecant theta times secant of theta. Alright, so in this situation we have an algebra problem where, recall that a over b plus c over d is equal to ad plus bc over b times d. So we're going to use that property here. So our least common denominator is sine times cosine. So this becomes cosine of theta, sine of theta, which is our least common denominator. And then they multiply each side by what's missing. This becomes sine of theta times sine of theta plus cosine of theta times what's missing, which is a cosine of theta. So sine times sine, sine squared, cosine times cosine, cosine squared. So this becomes, use red, sine squared of theta plus cosine squared of theta over cosine of theta sine of theta. And then from here, sine squared theta plus cosine squared theta is 1. So this ends up being 1 over cosine of theta sine of theta is equal to cosecant of theta secant of theta. 1 over cosine is secant of theta. 1 over sine is cosecant of theta. So recall the secant of theta. Remember that the letters switch, so this way you don't get it confused. So therefore, we end up with secant of theta times cosecant of theta is equal to cosecant of theta and secant of theta, which is a check because multiplication order does not matter. So, last problem, number 56. We have tangent theta plus cotangent of beta over tangent of beta is equal to cosecant squared of beta. Okay, so we have the same denominator for both, so we can split this. So let's do that. So this becomes tangent beta over tangent of beta plus cotangent of beta over tangent of beta is equal to cosecant squared of theta. So now, tangent divided by tangent is 1. Tangent divided by cotangent is the same thing as cotangent of beta times cotangent of beta, because 1 over tangent is equal to cotangent of beta, of course. Now, cotangent times cotangent is cotangent squared of beta. So this becomes 1 plus cotangent squared of beta is equal to cosecant squared of beta. And so thusly, using the Pythagorean identity, that's going to equal cosecant squared of beta equals cosecant squared of beta, and this is our answer. So we get everything we want. And so that's how we do these problems. We'll do some more later.